Heinemann Higher, Chapter 6 on Differentiation, the mixed exercise 6S at the end. Question 9, this is getting more like it, a bit more meat in this one, because it says sketch the graph of these functions. So that means I'm going to have to find out all the significant points on them. So general cubic graph, so I can expect it to look something like this. It'll have turning points, and then wherever the axes are, I'll need to find out where it cuts the axis. So, first of all, I'll do the axis first of all. So the easiest one is where does it cut the y-axis. That's simple. If you're on the y-axis, your x-coordinate 0. In which case, now since it's talking about the graph, but it did say the graph, so I'm going to be drawing the graph of y equals f of x. So I can talk about y here. So y would equal 0, 0, 0, 0. So it's the point 0, 0. Slightly trickier will be the points on the x-axis. Now on the x-axis there's no height, so the y-coordinate is 0. Well, that means I'm going to have to solve this equation equal to 0. So 2x cubed minus 3x squared minus 36x should equal 0. And the technique for this type of equation is factorise. Well, I can take out an x and be left with 2x squared minus 3x minus 36 equal to 0. Then ideally I would factorise this bit. But unfortunately it doesn't factorise, so I'm going to have to use the formula. So it's going to have to be x will be the negative of this, so that's going to be plus 3 plus or minus the square root of b squared, which is 9, minus 4a, so that'll be 8 times negative 36, all over 2 times a, 4. So it's going to be 3 plus or minus the square root of something all over 4. Then I'll have to work that part out quite quickly. That's going to be 288 added on to 9, so that's going to be 297. Then in this case use your calculator. That's going to give me negative 3.558, that's negative 3.56, or 5.058, call that 5.06. Bit of a pace, but at least I don't have to feed it back in here to find the y-coordinates, because I knew the y-coordinates were 0. So that's the first part. I know where it cuts the axis. So it cuts the axis at 0, 0, negative 3.56, 0, or 5.06, 0. The next part is to find where it takes its twists and turns. Where are the turning points on it? Well, I'll need more room. Right. We've got where it intersects with the axis. The only other significant points are where are the turning points. So differentiate it. Still using that functional notation even though it's the graph I'm considering. I've got 6x squared minus 6x minus 36. That looks very nice with all those 6's in there. And I'll find these stationary points when that derivative equals 0. Whenever the gradient is 0. So whenever this equation equals 0. Well, I could drop the 6 right out of it. So speaking, I could. I wouldn't take out a negative factor though, because that will influence my table of signs. But I could take the 6 right out, but I'll leave it in just now. So x squared minus x minus 6, easy peasy to factorise, because that's just going to be x times x, factors of 6 that differ by 1, 2 and 3. The negative goes to the larger one, and opposite signs. So I've got my two possibilities. Something happens at negative 2 and something happens at 3. So x equals 3. But for each of these I'll need to work out the corresponding y-coordinates. Feeding that one back into here. So that means y is going to be 2 times negative 2 cubed minus 3 times negative 2 squared minus 36 times negative 2. So that's going to be negative 8. So negative 16. 4, take away 12, plus 72, so that's going to be 28 away from 72, which is 44. So something happens at negative 2, 44. The other one, I better pop that somewhere else now, pop over here, x equals 3, that means y is going to be, same rule, 2 times 3 cubed minus 3 times 3 squared minus 36 times 3. So that's 27, so that's 54. That's 9, that's also 27. And then that's going to be 90, 108. So it's going to be 27 away from that, negative 81. So something happens at 3, negative 81. So there's the turning point. So here's my 5 points. Intersects with the axis, 2 turning points. But what happens? Well, it'd probably be sufficient just to draw the graph. And then putting the points in, there's only probably one possible way to snake through them. But I'll make up a table of signs, which I'll put here. I know this is getting a bit messy. So something happens at negative 2 and something happens at 3. I want to know what's the gradient before it, between it, and after it. Either by picking numbers and putting them into this expression, or this factorised expression, or in this case I think I'll just use my table of signs. I've got an x plus 2 and an x minus 3. 6 times it won't affect any signs, and the product of those two signs will give me the sign of the derivative. That's 0 here, so it's negative before and positive after. That's 0 here, so it's negative before, positive after. Multiplying them down, positive 0, negative 0, positive. So it's going up, along, down, along and up. So it's getting a bit messy, unfortunately. I'll better remove this little bit, which means you've got a maximum turning point at negative 2 and a minimum turning point at 3. And there's no surprise there, because look, that answer is higher than that answer. Then the final bit is just to put those two things together, those 3 points and these 2 points, in the final sketch. So that's the space cleared. Here's all the important information up here. There's the original function, which I want to graph. Here are the significant points on it, where it intersects with the axis, and the 2 turning points. And all I need is a set of axes. And I don't need a scale because it's only a sketch. I'll indicate where the points are meant to be. Then I'll need to show where do they cut the axis. Here. And where the turning points are. And then draw the graph through it. Like this. And that would be the solution then. That would be the graph of this function, showing all the significant points, where it turns, and where it cuts the axis. There's question 9a.